Good morning and welcome to Isham Live. My name is Drew Sabatis, Technical Sales Representative for ChemDAQ Incorporated. I'll also be presenting today with our Director of Sales, Matt Chittister. We would like to thank Isham for hosting the virtual conference and expo this year, and everyone for joining our webinar, Hydrogen Peroxide Sterilization. We've been on this ride before. All of us at ChemDAQ would also like to send a big thank you to all sterile processing technicians, managers, and support staff for all your hard work, especially during this pandemic. Please ask any questions during this webinar. We should have a little bit of time at the end to get to them. There is a form next to the video player. If we can't get to them by the end of the webinar, we will respond to you via email. Low temperature sterilization is a sterilization process best used for heat-sensitive devices that may be damaged by the condition of steam sterilization cycles. Ethylene oxide and vapor hydrogen peroxide are the two most common types of low temperature sterilization. Today, we will be discussing the similarities between ethylene oxide and hydrogen peroxide, best practices for hydrogen peroxide sterilization, and how ChemDAQ gas detection systems can make you aware of your environment and keep your employees safe. Both ethylene oxide and hydrogen peroxide are there to kill all life. These are used so we can ensure proper sterilization for all your medical devices. The vapor concentration inside a gas sterilizer would kill anything instantly if you were inside. Ethylene oxide is widely used in hospitals and sterilization facilities. It's colorless, odorless, and flammable. It's a known human carcinogen, mutagen, reproductive, and neurological hazard. OSHA has a PEL of 1.0 parts per million over an 8-hour time-weighted average, and a short-term exposure limit of 5 parts per million for a 15-minute time-weighted average. And NIOSH has an immediately dangerous to life and health of 800 parts per million. The epic of ethylene oxide. In 1859, it was discovered by Charles Adolph Wurst. In 1929, it was reported as a powerful insecticide. In the 30s and 40s, it was used to sterilize spices and other food preservatives. Then in the 1950s, it became a common sterilant for medical instruments. 1970, OSHA established a PEL of 50 parts per million for an 8-hour time-weighted average. Now remember that number of 50 parts per million for an 8-hour time-weighted average. In 1981, the ACGIH establishes a PEL of 10 parts per million for an 8-hour time-weighted average and suspects ethylene oxide as being a human carcinogen, but just suspects. In 1984, OSHA determines ethylene oxide presents a carcinogenic mutagenic hazard. 1987, the International Agency for Research on Cancer classifies ethylene oxide as probably carcinogenic to humans, just probably in 87. In 1988, OSHA establishes an excursion limit or short-term exposure limit of 5 parts per million for a 15-minute time-weighted average and a PEL of 1 part per million in an 8-hour time-weighted average. In 18 years, that exposure limit came down 50 times. 50 times. In 1990, the National Toxicology Program classifies ETO as reasonably anticipated to be a human carcinogen. In 1994, the International Agency for Research on Cancer concludes that ETO is a carcinogen to humans. So it took 7 years for that conclusion to happen when they first classified it as probably carcinogenic to humans. In 2000, the National Toxicology Program upgrades its classification from reasonably anticipated to being a human carcinogen. 10 years it took them. In 2003 and 2004, NIOSH reports that ethylene oxide causes breast cancer and lymphomas. In 2009, California adds ETO to its list of toxic substances. In 2016, the EPA publishes updated assessments of cancer risks 9 years after being advised by independent researchers. And that brings us to present day. So to summarize the roller coaster ride of ETO from 50 parts per million and maybe causing cancer to 1 part per million or even lower in some instances, and causing cancer, has contributed to hospitals to decommission ETO sterilizers and move over to hydrogen peroxide because of faster time cycles and the perception that that hydrogen peroxide is not harmful.
Drew, I got to weigh in here for a second. I believe you're accurate there, in shorter time cycles are one of the reasons, and the perception of hydrogen peroxide not being harmful. But I got to disagree. These chemicals, as you stated earlier, they're built to kill all life, so that the equipment and the devices that are used in surgeries and other areas of the hospital are safe for the patients that are going into their body or they're being used on. In order for that to happen, these chemicals have to do the same thing. They have to kill all microorganisms and all the bacteria. So if you're substituting one of those out for another one that's doing the same thing, it might not be the exact same, but it's going to have a lot of the same similar characteristics. So let me tell you guys a little bit about hydrogen peroxide. It's also a sterilant used widely in hospitals. Now, I've read on some sites and I've seen some different things around, even from manufacturers, that there's a belief out there that because people are so familiar with hydrogen peroxide, because you can buy it in a grocery store or a pharmacy, that it gives you a sense of confidence. Hey, we have this at home. It can't be that bad. It's not toxic, or it's safe. Well, the hydrogen peroxide you're buying at the grocery store is 3% by concentration, right? The concentrations we're talking about, the sterilizers you guys are using, which I'll get into a slide later, they're 50-some% concentration. And in special uses, it could be up to 90%. So it's 20 to 30 times the concentration of what you're getting at the grocery store. So they're not even comparable. Hydrogen peroxide is a strong oxidizer. It's more powerful than chlorine and chlorine dioxide. However, for disinfection, high concentrations are required. And that's exactly what's going on inside that sterilizer. When it comes in contact with flammable substances, it can spontaneously ignite. When it's mixed with organic matter, you may have a fire or an explosion. And when it comes in contact with certain metals or metalloids or metal oxides, it could also result in a powerful explosion. And this is why hydrogen peroxide is usually transported in diluted form and stored that way for safety. So again, I don't think something that has that potential can be considered non-harmful. So continuing on, it's colorless, it's odorless, and it's unstable. So you can't see it, you can't smell it, and how would you even know if it's present? It's a severe primary irritant. So exposure to hydrogen peroxide takes place through inhalation of damp or mist and through skin or eye contact. Hydrogen peroxide can irritate the eyes, skin, and mucous membranes. Skin exposure causes painful blisters, burns, and skin whitening. Inhalation of vapor can irritate the nose, the throat, the lungs, while higher exposures can actually lead to pulmonary edema, which is a medical emergency caused by buildup of fluid in your lungs. Exposure can cause headaches, dizziness, nausea, and vomiting. Exposure to the eyes of concentrations of 5% or more can actually result in permanent eye damage. Now, obviously, that's a little bit more tilted towards the liquid form of it. But if you had enough vapor and a high enough concentration and you were exposed to it long enough, you could have the same, you'd start with eye irritation, but if it was long enough or high enough, you could have some eye damage. Tests, it's a known animal carcinogen, right? So tests have shown with laboratory animals, according to the International Agency on Cancer Research and ACGIH, that hydrogen peroxide is carcinogenic to animals. There's no known relevance now to humans, but again, as we learned with the little roller coaster ride of ethylene oxide, it's just due to lack of research, right? I mean, I'm not saying for sure that it will be identified as a human carcinogen, but there is a lack of research out there to know whether or not it truly is. It's also been shown to be a mutagen. Now, a mutagen is something that changes or damages your DNA. Thus, it increases the frequency of mutations going on above the natural background. As many mutations can cause cancer, mutagens are also likely to be carcinogens. And again, that effect isn't known completely to humans because all testing has been done on animals and there hasn't been heavy testing done. As Drew said, with ETO, hydrogen peroxide has a similar OSHA PEL, permissible exposure limit, and that's an 8-hour average and a 1 ppm. And as you'll see in my time chart, that PEL is quite old. So here's just a brief little chart about the concentrations. Anything less than 8% is considered kind of non-hazardous, although I guess it depends on how much of it you would have. I don't know about you, but even though liquid detergent bleach is only 5%, I would not be, ingesting that. Obviously, hair bleach and over-the-counter grade. You can see it goes up to pool shock, 8 to 28%, and then it goes up to an industrial strength, and you'll find the first sterilizer there. And then you get to the 52 to 91%, and you get the V-Pros and the Sterads and specialty applications. So that's the concentrations that you're working with most of the time. And just another interesting note is if you get to 91% or above 91%, hydrogen peroxide is actually used as a rocket propellant. It's that unstable and that ignitable, causes ignition. So now we're going to look at the time chart of hydrogen peroxide. And you'll notice that there's some empty blocks, and I'll get that later. But hydrogen peroxide was actually discovered in 1818. It was used in the 1920s and 40s for various ailments medical-wise, slowed down a little bit in the 50s. And in the 50s when the ACGIH finally came out with a 1 ppm PEL that still stands to this day. So that PEL is 70 years old. In 1970, OSHA adopts the ACGIH TLVs from 1968. So now OSHA is also using the same 1 ppm PEL. In 1977, EPA registered hydrogen peroxide as a pesticide. If you remember Drew's slide, early on in its days, ETO was identified as an insecticide. Well, an insecticide is a specific type of pesticide. So some similarities there. In 1983, OSHA comes out with the Hazard Communication Standard, and this is basically safe use of chemicals in the workplace. So not specific to hydrogen peroxide, but hydrogen peroxide is included. In the late 1980s and early 90s, we have our first hydrogen peroxide sterilizer start to hit the market. In 1999, the IARC describes hydrogen peroxide as an animal carcinogen. And then in 2013, AMI releases chemical sterilizer standards, which is basically a general safe use and proper use of the sterilization in hospitals. Again, not specific to hydrogen peroxide, but hydrogen peroxide would be included. There's a lot of blanks here, and the reason is because if you look at the timeline of ETO and you see that all these blanks are filled, and you look at hydrogen peroxide, and we feel like there's a lot of blanks that still need to be filled in. So you see some similarities about how they're both older chemicals that have been around for a long time. You see how they have similar uses, identified as pesticides or insecticides, animal carcinogens. And what's interesting to Drew's point is ETO has been researched so heavily, they brought it down from a 50 ppm to a 10 at one point, and then to a 1 ppm, depending on the organization you're looking at. And now they're even looking to reduce that further. Hydrogen peroxide, meanwhile, sat there since the 1950s at 1 ppm, time-weighted average over 8 hours. So it doesn't even have a STEL for OSHA, which is a short-term exposure limit, and it's never been adjusted. So how confident are you that ETO has been adjusted so much and hydrogen peroxide hasn't? So again, these blank spaces are there because we feel like there needs to be more research done. There needs to be more studies, and we need to figure out how harmful it really is. And just to make a note, in certain places, and I'll talk about this going forward a little bit too, but in certain places, in certain states, Hawaii and Washington, they do have a 15-minute time-weighted average. and that's a 3 ppm. Other countries, the UK, certain parts of Canada actually use a 15-minute still, and that's 2 ppm. So let's move on. There's a little comparison chart. And you can see, again, the OSHA PELs are the same. The ACGIH threshold values are the same, all 1 ppm over 8 hours. Now, this is one that's very interesting. It's the IDLH, immediately dangerous to life and health. Now, this doesn't mean that you'll instantly die. It means that it's immediately dangerous to your long-term health and possibly to your life. So ethylene oxide is 800 ppm, hydrogen peroxide is 75. So ethylene oxide is 10 times higher. That means if in the room you're sitting in right now, there was 100 ppm of ethylene oxide, you wouldn't see it, you wouldn't smell it, you would have no idea, you wouldn't have any symptoms. If hydrogen peroxide in your room right now was 100 ppm, you also wouldn't see it or smell it, but you would be miserable. Your eyes would be irritated. Most likely your lungs or your nose would have some burning. You might even be knocked to your knees trying to crawl for the door. And that's, again, why it could become dangerous to your life, because if you're trapped into that situation where you can't escape, those effects could be deadly. And again, I'm not trying to scare, I'm just trying to say the fact, right? This is just, we have heard some cases of people, whether it's hydrogen peroxide or PAA, being put into these instances. And we just want to be clear with people that, it's a possibility, and you should always use safety as your friend. Moving on, the Joint Commission, they recommend monitoring hazardous gases and vapors to determine if they're in safe range. And they also recommend safe selection, handling, storage, transportation, etc. And they do that for both chemicals. They're both considered primary irritants. Again, they both cause eye irritation and respiratory distress. And ethylene oxide is a known human and animal carcinogen, whereas ACGIH has defined hydrogen peroxide as just an animal. But again, I'd like to see more studies and understand that a little bit better. If you look at, again, to Drew's timeline, how long it took them to actually identify ethylene oxide as cancerous, you're talking about 20 to 30 years from the first time it was brought up till certain agencies were willing to accept that that was the case. Then you look at the hazard communication, and employee training shall include at least methods and observations that may be used to detect the presence or release of hazardous chemicals. And one of the ways you can do that is continuous monitoring. That is there for both chemicals. And then you have Amy's recommendations. ST41 is specific to ethylene oxide. So it's saying that they recommend continuous monitoring as the workplace. And then there's an ST58 that kind of looks at all other chemicals, including hydrogen peroxide. And it also is saying vapor monitoring is recommended if there's a potential to exceed the OSHA PEL. So you have Amy, you have the Joint Commission, both recommending monitoring any chemical that is dangerous to your employees and could exceed the OSHA PEL. There's some studies out there. So, one of the things we look at as a company and for safety is malfunctions, but also just general use. So there's a few studies you can look at. ASP did a study a few years ago called the Comparison Study of Environmental Hydrogen Peroxide Levels. They found that various sterilizers emitted up to 20 ppm of fugitive H2O2 emissions, or vapors that escape after the chamber door was opened. So we're not talking about something leaking out or malfunctioning. It was a legitimate cycle that finished. Somebody opened the door, and these fugitive hydrogen peroxide emissions came out. So for whatever reason, during the process, the hydrogen peroxide did not fully break down or was not fully vacuumed out. And now the person opens up the door and it's right up in their face or possibly their skin. There's also an article by it's the CHL Self-Study Lesson Plan, and it was sponsored by Steris. And in that, this is a quote directly from that: personal monitoring should never be taken for granted. And employees must understand that 24/7 enviro monitoring is not always enough. Sometimes a combination of personal and environmental monitoring will meet or even exceed current regulatory requirements. It's equally important that the departmental staff also feel their safety needs are being met. Staff confidence can be supported through education and competency development. Personal monitoring devices should also be offered. Okay, so again, consistent across the board. It's talking about all these chemicals, even outside of ETO and hydrogen peroxide. Anything that's potentially dangerous to your employees or could go over the OSHA limits. There's also a study. It was about, it was several years ago, but it still was using sterilizers that are used today. And they measure the hydrogen peroxide concentration inside a sterilizer and immediately after the end of the cycle. When the healthcare worker would be reaching in to remove the load, they found high concentrations between 13 and 60 ppm. They also found that sterilizers sometimes emit high concentrations of hydrogen peroxide when they exhaust, even though it passes through a catalytic converter. So again, these machines are built to high spec, but sometimes the hydrogen peroxide escapes anyway, or sometimes there's malfunctions. They also found that the sterilized products continue to off-gas hydrogen peroxide after they've been removed. So off-gassing of sterilant gas is well known for ethylene oxide, but the study concluded that the same issue may occur with hydrogen peroxide. We've been a little bit familiarized with that recently because there's been some talk of that with N95 masks. But what if it wasn't just N95 masks? What if other products that you were sterilizing were off-gassing? But again, how would you know unless you had monitors in place to tell you if there was any hydrogen peroxide in the air? Of course, they say, no ventilation is needed for these machines. But in a perfect world, that might be true. But this isn't a perfect world, right? There's human error. There's machine error. There's, unfortunately, just sometimes things not working exactly how they're supposed to. There's wear and tear, right? Do you want to take a road trip in a car that's brand new or that's 200,000 miles? So you have to take that into consideration, and you have to do your best to protect people that are working around these chemicals.
Hey, Matt, I'm going to interject real quick. I was just doing some little searching on the internet while we were doing this and thinking about if someone did have a malfunction or an employee had an issue with hydrogen peroxide. I saw something from the FDA called the MOD database where they can kind of enter some of this stuff. You ever hear anything about that?
Yeah, actually, it's on my next slides here. So that's good research by you. It's called the MOD database. It stands for the Manufacturer and User Facility Device Experience. It's an FDA database that contains adverse events involving medical devices. The events are categorized into 4 types: malfunction, injury, no answer provided, and death. And it looks at the sterilizer and chemical events. We looked specifically from 2015 to 2020 currently, and we found roughly 1,000 reports of machine malfunctions. Now, again, it doesn't mean it's happening every single day or it's going to happen in your location. It just means it might occur, right? And you're talking anything from simple as a basic malfunction where there was no injury to fires or to people being sent to the hospital for major burns. So, it's something you can take a look at, or, if you feel like you've been put into that position of having an issue or a burn or a close encounter, it's something you can actually report on your own. I have 2 right here I can tell you about. The first one, the event was the facility reported an employee experienced a burn while handling items that were processed in a vPro. The technician found, when they sent the technician out, he found the unit to be operating according to spec. No repairs were required, and the unit was returned to service. The facility also confirmed the employee was not wearing proper PPE. So wear your PPE, okay? At all times, you should try to be wearing that PPE if you're working at all close to these chemicals. The sterilizer operator manual actually says, danger, chemical injury hazard. Any visible liquids in the chamber or on the load must be treated as concentrated hydrogen peroxide. So again, if the process doesn't go right, there is a chance for residual hydrogen peroxide liquid to be left on the product. And if you touch that, it's going to burn you. And if there's liquid there, there's going to be vapor there that you could breathe in. So you should ensure, right here, it says you should ensure all instruments are properly dry prior to placement. And if you don't do that, residual hydrogen peroxide may remain at the end of the cycle. So that's one example. I have another example here. Now this was a different, this was a stare ad. A customer reported an odorless vapor or smoke. And the healthcare worker experienced irritation, burning, and itchiness of the eyes. He took off his contacts to rinse and flush his eyes. The reaction lasted 4 hours. He had a light headache, which lasted an hour, and he did not receive medical attention or treatment, although he probably should have. The customer was advised to clear the facility and shut down until the unit was serviced. Now, in this case, they replaced several things, and adapter converter, catalytic converter, oil mist filter, and vacuum pump, and that resolved the smoke and haze issue. But if that smoke and haze is getting out, most likely the hydrogen peroxide is getting out with it. And, his injuries could have been a combination of the two, or specifically the hydrogen peroxide. So these two examples show you that, sometimes people go to the hospital, sometimes they don't. Sometimes there's injuries, sometimes there aren't. We also believe that, this is just, I don't believe that everybody reports them, right? A lot of people are afraid to complain, or they chalk it up to allergies or a sickness they're having. They don't want to be, shamed by other employees or managers for complaining. And other workers have become accustomed to the exposure. I've been in the hospitals where they kind of joke about the chemicals that they're working around, and they're going to lose a few years at the end of their life, or the smells that they've become used to. And I just don't think that's right. These people should feel safe to be doing their jobs, and they should feel comfortable reporting issues. So what can you do? You can eliminate, you can physically remove the hazard. Well, obviously that's not going to happen because we need these machines. You could replace the hazard. Again, you're just going to replace it with something else that's equally dangerous. So what can you really do? You can educate and train. You can use engineering controls. You can make sure people use personal protective equipment. You can make sure your sterilizer is reprocessed and maintained. And you can use continuous monitoring solutions. So education and training, follow your device and your sterilizer. These are kind of the 3 or 4 most important ones to me. Follow your device and sterilizer manufacturer's written IFUs. Actually read those SDSs. You'll learn a lot about the hazards and the handling and the use of these chemicals. Look at the labels, get some training. Take a look at some of the laws. All you have to do is Google OSHA or the OSHA Act. You could look at the air contaminant standard or the HAZCOM standard. Excuse me. Personal protective equipment. Again, use goggles, use approved gloves, use impervious clothing, approved boots. You should always be prepared in case you come across that liquid or that vapor. It's not worth taking the chance and just assuming that it's not going to happen. Then I find this one to be interesting. I found this right on an SDS sheet. If concentrations are in excess of 10 ppm, then you should be using a self-approved, self-contained breathing apparatus. Well, how would you know that the concentrations are in excess of 10 ppm if you don't have a monitor there to tell you? And then one last thing is just always try to avoid, if you are near some of these machines, directly breathing in the vapors, the mist, or the gas. So one of the ways people have done this in the past is they've used badges. They're cost effective. They provide time-weighted averages. Unfortunately, their accuracy is only plus or minus 25%, and you get the results a week or 2 after the incident. So, how is that going to help you if you find out a week or 2 after you were exposed that you were exposed? That's like having a fire at your house, but not knowing about it until 2 weeks later. And actually, it's not even that, because a fire, you can see the smoke and the fire. You can't see or smell this. So it'd be more like carbon monoxide in your house. And that's why houses they're required to have carbon monoxide detectors.
So I know, Matt, you said this was an accepted method, right? But not the solution. Well, we at ChemDAQ think we have the solution. An electrochemical sensor is about 10% accuracy compared to the 25% accuracy. And it provides real-time, instantaneous, continuing monitoring. This will give you a real-time measurement in parts per million. It will display 15-minute and 8-hour time-weighted averages. It has a built-in low-level and high-level alarm. It has data reporting and archiving. So if the Joint Commission or OSHA were to come in, all that information is saved for you. And it has the ability to connect to a control system and HVAC, external alarms that you may already have in place. 2 options we have at ChemDAQ are our SteriTrack 2 system. Again, it's a continuous fixed monitoring system. We've been using this for ethylene oxide for years and hydrogen peroxide as well. We also monitor parasitic acid, which many of you use in your sterilization departments. And our second option is our SafeSide 2.0 portable monitoring system. This is a brand new system for us at ChemDAQ. It's an Android-based system that can connect to the cloud. We've been using this to do a little bit of off-gassing studies with our N95 masks. It can also be used for personal monitoring as well as spot checking in different areas. And even environmental services can use this to check if they are fogging rooms for hydrogen peroxide, or even we've seen some parasitic acid fogging happening lately that they can check to make sure those rooms are safe to enter.
Right, and Drew, I don't want to get into cost, but with the cost that with hospitals spend on coffee and other items and cleaning supplies and whatnot, we're talking about a small investment that you could have environmental monitoring of that room, with our stationary SteriTrack 2, and you could provide a portable Android handheld to do spot checking and personal monitoring. So that person that comes to you and says, I'm telling you every day I'm exposed to this, you could put this sensor on them for an hour, 8 hours, or their whole shift and see what they're really exposed to. And at the same time, you can see what's coming out of these sterilizers, if anything. And again, we're hoping that nothing comes out. We really are. But how would you know if anything's coming out, right?
Well, I do have one question. We want to thank you guys for joining. And we do have I had a couple questions come in, but one that we see a lot and I think is important to answer, and I'll even just throw this to Matt. Should we be monitoring hydrogen peroxide like we do for ethylene oxide?
Yeah, I mean, I think with what we've talked about, and we've just kind of touched the tip of the surface here with 30 minutes, but it's a harmful chemical. It's used to kill all life. Again, these manufacturers do a great job of producing high quality equipment. But if you look at the fine print and all the SDSs and the manuals of this equipment, there is human error, there's sterilizer error, malfunction, as we said in the mod report. Things happen, and you should be caring about the people that work for you. And I think when they know that they're not exposed to things, it's proven that you're gonna have people that work a little bit harder and a little bit more satisfied with their job. You don't have to worry about, you don't have to send somebody off to the hospital. Not only is it bad for morale, but then you got to fill his shift, or if he or her is out for a while, you got to find somebody new. If you have a high turnover, you have to replace these people. So yes, and again, there hasn't been much studies done on hydrogen peroxide. So we don't exactly know. The PEL has been the same for 70 years. So what if it continues the ride of ETO? And what if we start discovering more stuff? And again, I'm not guaranteeing we will, but we need to study and find out.
So our time's up, folks. Any other questions you have, please feel free to put them on that form. We will get back to you via email. You can also check out our website at chemdaq.com for any product information. And there's a lot of information just regarding not only hydrogen peroxide, but ethylene oxide and parasitic acid as well. So we really appreciate you for joining us, and we really appreciate Isham for putting this on. And I think we would all like to have been in Chicago in April, but unfortunately, this is the way we had to do it. And Isham came through and did a great job, so we could all connect virtually here. So thank you very much.
Thank you.